Okay. Hello, everyone. And before starting, everyone has a computer with a VirtualBox or something to emulate, have a virtual machine on it. You can Okay, with the Wi-Fi network of the conference, DAP1155, you can go to this address at port 8000, and you should find the virtual machine, a zip with the virtual machine. You can download. There is all the tools already configured, so you don't have to lose a lot of time. I hope it works. Please don't hack my computer. Okay, we will need just some, SDR libraries for the SDR dongles, and Audacity for analyzing the signal, Baudline for analyzing the signal, and GQRX for viewing the spectra of the signals. Is the RTL SDR from I think it's using the R820T2. I think the standard one. The standard libraries should work. Or if you use Osmocom, that's good. If you use the Osmocom libraries. If you don't, just download the virtual machine. Tell me if everything works.
What is 800?
8,000.
So from here, the IP address is not...
Sorry, I read. 192.168.12.98. Yes, that's it. Should be around 1.5 gigabyte, something like that. Okay. Sorry? Yes, 192.168.12.98. Sorry? Okay. While you download and unzip the virtual machine, let's start with the introduction of the presentation. Maybe? Okay. So, a little about myself. I'm Matteo Beccaro. I'm a founder of a new company in Italy. We focus on physical security, so electronic access control is, of course, part of the job. And these are just some reference if you want to stay in touch with me. Okay, the address is obviously wrong. And inside the virtual machine, you'll find the virtual machine itself, the installer, and maybe the guest edition. You need the guest edition just because you need to plug the USB devices for the hands-on part and the final challenge. Okay, what are we going to talk about today? I'm going with a little bit of introduction. So what are access control systems? What were access control systems? And then I start focusing on NFC-based access control system. What are the tools you can use today to assess those systems? And I'm trying to give you a high-level methodology to assess those ecosystems. And then we have a little part, a little practical part, in which I will give you Hydra Bus and Hydra NFC. You will read a couple of MyFair cards, and we try to use the methodology I spoke before to analyze those tickets. And then I go with the two very simple cases I happen to work in a real environment. Then we go with the radio frequency communication part, and here we will see where radio frequency communication are used in access control system. We'll try to explore some of the radio frequency communication in practice. You will work with your computer and try to receive a FM radio station. And then we start with a little bit of signal intelligence. So once you have the signal, try to understand it and try to decode it and see what are the characteristics of the signal. And then we speak about the security of radio frequency communication. And then we have the challenge. It's very easy, just 15 minutes of challenge. And the first 3 guys who solve the challenge, I will give away some of these dongle. So let's start with the introduction. Okay, what was an access control system in ancient time? In ancient time was something like this. You can have walls, you can have like a bridge, big doors, and maybe some soldiers on the walls. At the time, the first hackers who were against the access control system were or magicians, like this one, or they social engineers, like this one. So nowadays, access control system is something like this. That's how it usually works. Okay, what are the technologies used in access control system? We can have NFC, radio frequency, biometrics, magnetic stripe, mobile phones, etc., etc., etc. There are dozens of different technologies you can use for an access control system. We will focus on NFC and radio frequency. Just a second. Okay. For NFC, let's start with from the beginning. What is NFC? NFC is near field communications. Has a frequency of 13.56 megahertz, a very short range. Maximum is 5 centimeters if you don't use huge antennas or amplifier, whatever. And you use for access control system, electronic ticketing systems, and mobile phone. If you have an Android phone, you probably have NFC. If you have an iOS phone, you probably have NFC for payment and whatever. Okay, what are the families? The most famous families in NFC? We have the MyFair, which I think everyone knows. There is the HID I-Class, Calypso, and Felica. Felica usually in Japan, and Calypso in Europe. The virtual machine is fine. Everything can download it. No. Okay.
Not at all. So we need the address and the port number and the protocol, and maybe we can... Port is down. Port is down.
Okay, who hacked my computer? Raise your hand. Okay. Just a second.
Is the IP 12.98 at the end? Is it correct? IP?
192.168.12.98, but they said it's down.
Yeah, no, IP is up. IP is up.
The port is down. The service is down.
Yes. Port 8000 is not responding yet.
Port 80 is okay, but
Okay, who's DOSing?
port 80 is up, but port 8000 is down.
What is on port 80? Who opened port 80?
There's port.
Okay, good. Let's do it this way. Okay, this is a USB key. It's my USB key. So please return it back. There is the VM and probably some shit that Mac puts on it. If you have some USB key, I can copy from the computer. No malware on USB keys. Some 0-day maybe, but with description. You're right. It doesn't work. So, okay, I'm sorry for this. I hope Apple would make better computers. I can wait for a few minutes for you passing along the USB keys, and meanwhile I go with the theory part.
Можете дать мне флешки, я вам скопирую. Так, возможность.
Exactly. Okay, so let's start with my fair classic. My fair classic was, I think, the most famous NFC token out there. One of the most famous MC tokens out there. He has a wide memory, like from 1 to 4 kilobytes. It was supposed to have a strong access control mechanism. You should require you have to provide a key to access the data. And he used a custom algorithm called Crypto1 and renamed by some hackers Crypto1. So you can suppose that the algorithm was not so good from the name and was broken. But from my experience, they still sell it. So if you have a new building, you can find my fair classic in there. So it's very strange. Then we have MyFair Ultralight. MyFair Ultralight usually is used in transport systems, mostly, because it's cheaper, it's disposable, and it doesn't have a lot of security features and a lot of memory. It just has 64 bytes of memory, of which like 46 are usable for data storage. Then we have some basic security mechanism. We have the OTP, which is a sector you can program just once. So if you turn some of the zeros in this sector to 1, you can turn back to zeros, theoretically. Then we have the lock byte sector, which are used to set some of the other sectors in some sort of read-only mode. So you can write on those sectors. It has some children, let's say, Ultralight C and Ultralight EV. Those are required. One of these, I think, the Ultralight AV require authentication. It has like AES authentication, while the Ultralight C requires a password for accessing the sectors. And then we have MyFair Desfire. Again, pretty big memory size, some advanced security mechanism, FreeDes, etc. There is a file system structure, so you can have folders, you can have files inside the folders, counters, whatever. And there is some variants. You have the Desfire first generation, which is broken. They developed some side channels attack on that. So if you search online, there is a research from guys in Germany. The same guys who built the Chameleon, which is a tool I'll talk later, who broke the Desfire with some side channel attacks. Then they created the Desfire AV1 and the Desfire AV2, which, as far as I know, at the moment are still secure or something like that. If you have more information, put on your USB key and give me the key. Then we have the iClass. iClass is a very broken token. They use the same authentication key, keys for all the I class in the market. So the reader has embedded the keys, which can be used to read all the I class tokens. And the keys, of course, have been extracted. So, everyone can read all the tokens, everyone can write on the tokens, etc. There is two variants, the I-class standard, which works, like I said before, so everyone has the keys. And then we have the I-class, I-secure, which are in which you are supposed to provide the key for your own organization. Both of them are broken. For both of them, it's possible to retrieve those keys and to use them to read the tickets from distance.
It's possible to clone I-class card.
Yes, it is. You can actually. It's more easier to emulate I-class. For example, with the Proxmark. Yeah, it's possible. Just.
Proxmark is not so good.
No, Proxmark sucks, but it has the widest community behind it. So for some things, you have to use the Proxmark at the moment. Okay. So what are we gonna do now? We are trying to create a common methodology to pen test those systems, and for doing that, we need to have some tools which can help our work, and we need to have some references and best practice to provide help during an assessment for the client. Okay, this is just a little schema of what an ecosystem in an electronic access control system is. We have a token. We have one or more readers which are communicating with a controller. The controller is communicating with a backend system, and the backend system can communicate with some clients. The clients can be web application, can be mobile application, can be information system, whatever. So let's start with the token. Okay, before I start with the token, how is the VM process going on? Who has the VM now? No one. Where is my key? Okay. So you have the virtual machine. Anyone else? You have the two. Free. It's not a very good percentage, but sorry?
Did you bring the web server down?
Yes, because someone hacked my computer. No, I'm joking. It doesn't work. I mean, it crashed. Too many people. So I'm giving a USB key.
But can you maybe still bring it up?
I can try.
Maybe.
You didn't download everything from my computer yet, so you need...
No, not yet. So I need it back.
Sure. No problem. Just leave my porn, please. Okay, should be up.
It's called VM.70.
Yes, that's it.
VT and VM.70. Okay, it once responded.
For now. Okay. Okay, so the token. The token usually is a NFC card. Can be, as I said before, a ultralight card, a classic card, a HID card, or another technology. And the card usually can store the timestamp when you stamp the card. Can store the details of the location where you use the card. So if you use for an office or for the main entrance of the building or whatever, can store the credential, the access level of the person with the card, several information on which we can perform some attacks. Yes.
What is the password for VM?
You're right. The password is no, right. It's very, very strong. Sorry.
1, 2, 3.
No, very, very strong. I said.
3, 4, 5.
Yes. No, it's I write it. Sorry, I forgot to write the. You're right. So OP4 is the abbreviation opposing force and 2016 is this year, so no problem. Okay, so username and password for the virtual machine, and also for my computer.
Ребята, кто скачал, можете поднять там FTP или что-нибудь?
Davai. It's the only word I know in Russian. It's davai, nadivai, and something like. No, it's something like Yosha, something refill the glass with other alcohol, something like that. Yoshai. Yeshua, that's one. Oh, also nastoika. I survived 3 days with those 4 words in Russian.
You know Russian now.
Yes. Okay. Let's back on the token, and we said that my fair classic is broken, so it's broken. You can crack the keys. If you have one known keys on the token, you can crack the other very quickly. If you don't have one key known, you can crack one key and then use the same process to break all the other keys. My fair ultralight is not completely broken, but mostly. We have 3 attacks I developed in the past. We have the lock attack, time attack, and reply attack. I won't talk about that now here. I have another speech tomorrow. If you want to know more about those, come tomorrow. And then we have the HID, which is broken again. So at the moment, if you want to create an access control system for your organization, for your building, go with the desk fire, AV1 or AV2. Okay, then we have the readers. The readers usually operate online. Online, I mean with the backend systems, but can also operate offline in some cases, in small offices or whatever. And if they operate offline, that means they store all the details of the authorization codes or whatever inside the reader. So if you can open the reader and dump the memory from the reader, you probably can have access to all those details. There is too many people here. I don't have enough hardware for you. I'm sorry. Okay, whatever. Usually supports multiple standards, so you can use MyFair Classic, you can use MyFair Classic Plus, you can use MyFair Deskfire, MyFair Ultralight. They are all compatible. They can store secrets and keys for authentication with those tickets. So as we saw before with the HID, every reader has the same keys to access the tokens. So you just need to broke one of these readers to get access to all the keys for all the tokens. So usually what it does, it reads the tokens data, and sends those data to the controller, and then give a feedback to the user, like a green light or a beep or whatever. All the other operations, like opening the door, like verifying if the data is correct or not, are not made by the reader if these operate online. If it operates offline, everything is done by the reader. And usually it's connected, wired, to the controller. Usually use or the serial protocol, Ethernet, or the most common is Weigand. Some of you have heard of Weigand. It's a very simple protocol. You have 2 wires. If the first wire is powered, the signal is 1. If the second wire is powered, the signal is 0. There is no encryption usually. There is no authentication. So it's very easy to sniff this data. Okay, then we have the controller. The controller is connected to the readers and to the backend, of course. It can use one of the same protocols as I said before, receive the data from the readers, and send the data to the backend. And then, based on the feedback from the backend, it can operate on the door, like opening the door or denying the access and giving a feedback to the reader for the user. So it's a very interesting thing to test, because usually it has like network interface. Sometimes those controllers has been found vulnerable, and so you can connect to it if you are in the same network, add new users, and then use a card you just create to access the building. So there is serious stuff about the controllers. Okay, then we have the backend. It can be on cloud, like it's buzzword nowadays, or it can be like offline, or on like a bare metal server stored in the building. again, it connected to the controller and perform multiple operations, like control the token validation logic. So it has a database with all the credentials and checks if the data arriving from the controller is present in this database. You can get some statistics, some logins, some anti-thief prevention or detection. Like sometimes if a token has been used twice in a very small time frame in a very distant doors, it can give you an alert or something like that. Something is wrong, someone maybe have cloned your card or whatever. Okay. Now, the weapons we can use for attacking those systems. There are more. I just trying to give you the better one, I think, the most used at least. We have the Hydra NFC, which is what we will use today. Then we have the Proxmark, which is the most famous, I think. Then we have the Chameleon Mini, which is this device created by the guy who broke the Deathfire. And then we have NFC Cult, which is an application I developed, which is used mostly on a focus field, which is ticketing systems. Let's start with our Hydra NFC. It's a board which costs like 100 euros, more or less. It's very easy to use if you have also the Hydra bus, which is another board. Let me show you. Okay, so this is the Hydra NFC. It's a very small board with some pin connection. You can use something like the Bus Pirate to communicate with that, or the official support board, which is the Hydra bus. And then we have the antenna. The antenna is, of course, for reading, emulation, sniffing. So the most interesting things about the Hydra NFC, I think, is at the moment the sniffing feature. You can have an official reader and an official token, and put the Hydra NFC in the middle and see the communication. It also gives you an idea of who is sending what. You know that this data is being transmitted by the reader, or you know that this data is transmitted by the token. So it's quite useful for that. And also the guy behind the board is developing a lot in the last weeks. And just tonight, he pushed a new update on GitHub for the Hydra NFC, for emulation with MyFair Ultralight. So now you can emulate a MyFair Ultralight with this board. Okay, the Proxmark is a bit more expensive. It's like 200 euros. But he has high frequency and low frequency capabilities, which means it can operate both on 13.56 megahertz and 125 kilohertz. It has a very large community behind. You can find the forum with the awesome guys there. And supports very, very wide range of RFID and NFC tags. Almost everything you can think about is supported by the Proxmark. If it's not, learn how to program and you can add the support. Also, the Proxmark supports sniffing and emulation of tokens, but it costs twice as the Hydra NFC. Then we have the Chameleon, which started a Kickstarter crowdfunding campaign a few months ago. Now it is ended. The one in the picture is the previous version. I have one of the previous version. It works quite well. It's same price as the Hydra, has more software capabilities at the moment, but it's less stable. I mean, sometimes it can give you error, it can give you bad data during the sniffing or whatever. At the moment, the firmware for the new revision is not yet available. At least I didn't find it. so you can use only the old version. And then we have NFC cult, which is what I develop. It's a very ugly application for Android phones. I'm very bad with the UI graphics or whatever. He designed for pen testing ticketing systems and implement the attacks I researched about in the past years. I added some custom mode for reading and modifying bit by bit the data, and supports only ultralight at the moment. I will implement support for MyFair Classic because now I have a phone which supports MyFair Classic, so I can work on that. And from the point of view of this presentation, the most interesting things is the custom edit feature, in which we can modify each bit of the data and try to write on the token and see how the system behave on that modified data. Okay. As you can see, we are near the hands-on part. So how is going with the virtual machine? Since no one is raising. Okay, okay. We have like 2% now. 3? No, 1? 1, 2, 3, 4.
Just question. And what NFC modules in our phones, in iPhone, for example? It's MyFair?
No, in iPhones is very, very close. You can't read tokens. At the moment, I think you can also only use it for payments, because Apple doesn't allow any open APIs to access the chip. So, and I really don't know, because I don't have an iPhone, I don't have a device, an Apple device with NFC capabilities, but from what I heard, there is no possibilities to read a token with the iPhone. I don't know, maybe if some of you knows better about Apple ecosystem.
And what about Android phones?
Yes, Android has a series of APIs in which you can access most of the known chipset, like MyFair Classic, like MyFair Ultralight, like some other chips. And moreover, it also has some low-level APIs in which you can send like raw data to the chip, and so you can also have support for unknown chipset.
And we can use Android phone as a sniffing tool?
No, you can use it for reading, for writing and emulation. For emulation, you need like I think a special version of Cyanogen mode ROM, which had the support for emulation. But the hardware on the phone has these capabilities.
Thank you.
What you are trying to emulate in Chameleon Mini successfully?
With the Chameleon, I emulated a couple of MyFair Classic during a penetration test and a couple of MyFair Ultralight.
You try 7 bits, my friend.
No, I didn't. I never seen one in my experience. Just 4 bytes YD.
We have 7 bits ID in the subway.
I don't know. I think Hydra NFC is adding support for emulation the UID of 7 bytes. Yeah, I know. But I think it's doable. I think the guy behind Hydra NFC will add support for that. Actually, I'm in contact with him, and he said that he's working now on the NFC part, because he's also developing the Hydra bus board. So he doesn't have a lot of time. But MyFair Classic emulation and MyFair Classic reading is one of the milestone for the project. You know, I think he will have support for that.
I built the Chameleon from scratch, print the PCB, soldering it, and I have 1 of 10 successful fuss.
That's not a very good rate. I think that's why they are doing the new revision, maybe to add more stable support for it. I don't know. I was in contact with them some times ago. I was thinking to bring the Chameleon here for the hands-on. I mean for hands-on, so like 20 boards for everyone. But they didn't have it ready yet, since it was a Kickstarter campaign. So let's back with our. Okay, that's the Chameleon. Let's. Да. Okay. that's our schema of before. And for pen testing the schema, let's start with the token. What are the characteristics we are going to look for the token? The attack surface of the token is composed by the NFC interface, the hardware board, and the memory. In NFC interface, we can analyze the authentication mechanism, and for doing that, we can sniff the authentication, like with the Hydra NFC or the Chameleon or the Proxmark, and try to see if something wrong. We can also try to look at the papers online if there is some white papers on how the authentication works, how the data is sent or received. An example of that is the MyFair Ultralight C, in which we have just the authentication. MyFair Ultralight AV, in which we have the passcode for accessing the data, but then the data is sent in clear. So if we can sniff the communication, we can also see the data, even if we can't read the token itself because we don't have the passcode. Then we have the hardware board, which is the hardware chip inside the token, and there we can do some side channels attacks, like the German guys did for the MyFair Deathfire. And doing these attacks, you can extract or dumping the data, guessing the keys, whatever, and then you can use those keys to emulation or other stuff. And then we have the memory, in which we have, in my experience, I see a lot of bad implementation of the data inside the memory. For example, we had this penetration test in which there was a MyFair Classic infrastructure, so already broken, but the access level was not on the database online, but was inside the token. So if I can read the data and modify the data on the token, I can also elevate my privileges and access to restricted areas or whatever. So I just need to clone and read a token from a guest, for example, or make the company give me a guest token, and then I can elevate my privileges. And this is a logical bug, and we can find it in the memory. Then we have the reader. And again, we have the NFC interface, in which we can do the same thing as the token, so analyzing the authentication mechanism. Then we have the hardware board, in which we can try to extract or dumping the firmware, extracting the keys. And this is what was done for the HID. So they took a reader, they extract the keys, and then found out that all the readers were using the same keys. And then we have the connection. As I said before, if the reader is connected to the controller via Weigand protocol, we can just intercept the data, and the reader already authenticate with the token, get the correct data, and send in clear text to the controller. So if you can attach ourselves in the communication between the reader and the controller, we get the clear text data. There is also a tool called, okay, I don't remember the name, which was presented last year at the Black Hat US, which was basically a Weigand reader, very small. You can put inside the reader and controlled by Bluetooth. And from your smartphone, you can see the data passing, save those data and reply back to open the door, or trying to do some brute force attacks and send the access code, trying to brute force the access code to open the door. It was very nice. It was a board like 1 centimeter per 1 centimeter, very small.
That device is able to transmit to the Weigand?
Yes, it can read and write on the Weigand protocol, and he has Bluetooth chips to communicate wireless to the smartphone. So it's very interesting. I try to remember the name and. Okay, then we have the controller. And as I said before, the controller can expose some network services. And those network services are several times vulnerable. So we can hack the controller, try to get privileges on the controller, and add new data, new users, new privileges, escalate our privileges or whatever. There is also, of course, the Ethernet or serial interface from the controller to the reader, from the controller to the backend system. And then there is the hardware board, in which, again, we can try to extract the firmware, extract the keys, or some secrets inside the controller. Okay, then we have the backend systems. The backend system has a web application usually, or a mobile application for the people who are supposed to check your access control system to verify who is getting in, who is getting out, who try to create new badges or whatever. So we can test those applications. We can test the network services exposed by by the backend, and we have also a problem sometimes because the server maybe is inside the building but not very well protected. So if we can access to the server, we have a physical access, and we can basically do whatever we want, attach a USB key, a keyboard, and add data, or whatever, add a backdoor. Okay, then we have the channels, which, okay, this is wrong. Okay, don't look what is it? Okay, don't look the first line. We can have external wires, like from the reader to the backend, from the reader to the controller, to the controller to the backend, and we have maybe sometimes wireless connection, and often they use like custom protocol for radio frequency communication. And it's been seen a lot of time on the web. The custom protocols are almost all the time broken. We will see that later with the radio frequency part. Okay, now we have the little exercise, and all of you have the virtual machine, right?
Yes. It's running.
It's running?
Yes.
Okay. Who has not the virtual machine yet? Wow, 100%. My USB key is still alive? Perfect. Okay, run the virtual machine and come here and take a board. So we do a little exercise.
We need to give them back, right?
Yeah. Possibly, yes. One. Yeah, USB cables. If you need a USB cable to connect to the computer.
One or two?
Yeah, it's the Hydra bus, and that's the Hydra bus and Hydra NFC.
I need two.
So we need two.
No, one. This,
One at a time.
you will connect this to the other board with this pin.
Okay.
So, oh, wait.
Thank you.
For the virtual machine, OP SO R 2016.
Okay, thank you.
You need the
Okay, maybe three.
three. I have just two. I'm out of them.
Okay.
Oh wait. I have three. Okay, two.
Five.
ask him, if it's free. I don't know if you need all of them. Okay, at the end you should have something like this, without the case.
So we need to assemble it now, right?
Yes, that's the interesting part. The funny part is, it's like IKEA. I don't know how to say Russian. IKEA. You know, when you have to build your own. Sorry?
To any side, because it has the same. You attach this to any side, right? Doesn't matter. Or it matters.
Yeah, it matters. That's correct. You also have to attach the antenna. On the upside, and you put the board in this way.
So
Thank you.
What do you mean?
the board is put on the same side as the USB ports, right?
Oh, I'm sorry.
What about antenna?
Okay,
Is it needed?
this is not needed. You just need to. Okay, for the antenna. Okay, then just need to attach those two.
Yeah, but I miss this one.
There is any left?
Oh, there's all right. I'll do it.
Yeah, there is one thing which is.
Okay.
the gentleman in the gray suit. Do you have one?
No.
Okay, so
Okay, everyone has his Hydra bus connected to the computer. Yes? Okay. Just need to... Why? You don't see anything. Yes, the device is called, yes. Open Moco Inc. Hydra bus 1.0. Okay, now why we don't see anything in this? Sorry? We are going just to... Okay, the Hydra bus does expose like a serial interface. So we can just use like screen and connect to the device. Oh, okay.
Should we do it to 0 as well?
Yes, 2.0 is correct. 3.0 is wrong.
We can check the device before starting.
To put it on the... Ah, okay. It worked like sharp.
Yes, 2.0, yes.
It's working. You can connect to it.
Which port it will open, do you know?
dev/tty.usb modem something. USB modem 301 or USB modem 401. Okay, let's try it.
Then unplug for start. Unplug. Unplug. Then start. By the way, I see many...
What's the TTI number?
Okay,
It should be TTY AC something, I think, ACM. I mean, you can do tail...
yes.
ACM 0.
Yes.
ACM 0.
If you open it, you should see like a prompt, a command prompt.
I use screen, but...
Yes, it doesn't work. Wait just a second. Yeah, that's the you use like just the gate, but not on the string.
Your cable
Wasn't working.
it was working. So...
Ah, okay, right. Try.
It works? It works? With the pseudo prefix?
No, with
Okay, was the cable was...
maybe...
Oh,
Maybe
okay.
cable, maybe something else.
Okay. If you now if you connect it to the machine.
Okay, after studio it works.
Okay, if it doesn't work with screen, try giving root privileges with sudo. It should work. Now, yes, sudo. Yes, this is one. Okay, so now sudo screen slash dev TTI AC 82 application. Okay. we are very, very, very late. And it can be my fault for the virtual machine, sorry. Now, if everyone has this Hydra NFC connected, sure, sorry. Now mine doesn't work.
Maybe increase font size.
Better? Okay. Okay, just a second. I close this. Okay, you should see something like this, a prompt like this. Everyone sees? Perfect. So with the help, we see the list of commands available for the... Oh, yes. With the help, we can see the commands available with the Hydra bus. Sorry? Yes, it's like screen. You are using the virtual machine. It should be TTI ACM0. Yes, with sudo.
Yes, so sudo minus E before.
Okay, so from here we can access the submenus. The one we are interested now is NFC mode. So we just write NFC and press enter. And now we have in the NFC menu, we can do also again help. And as you can see, we have several options. We have the scan option, which returns the UID of the device, of the token, sorry. And then we have the sniff option, which, as I said before, can intercept the data between the reader and the token while the readers read the token. And then we have emulate. You should have one option more here, which is called read something. You have the option read. No, you don't? Wait a second. Okay. The option is scan. Now, I give you some tickets. These are some dumps I made from a real penetration test we did in ticketing transportation systems. These are 2 tickets disposable, one with 3 rides and one with 2 rides. And they were stamped at different times. So now we try to read the tickets with the Hydra bus and try to identify the data on the ticket in order to find some vulnerabilities. Okay? Yes, you should read both. To read the token, you just need to put the card on the antenna and press scan. The scan will give you the ID of the token and the data stored on the token.
And it gives the data if it knows how to read the token, right? So for example, I just tried the Metro,
Yes?
Moscow Metro one, it doesn't give the data, it gives just the UID.
Yes, because now the metro station is said was MyFair Classic, right? MyFair Plus. Now we are working with MyFair Ultralight. So with this firmware, we just have support for reading MyFair Ultralight at the moment. But for example, if you use the sniff option, you can see the data of all the tokens which are using this protocol with this ISO. So you can also read the MyFair Plus if you sniff the data between the reader and the token.
Okay, but you have to be in between.
Yes, because there is no encoder or decoder for the data of MyFair Plus yet on the software, on the firmware. Okay, everyone is a...
You have 1 card, right?
2 cards. Yes, sure. I was just showing the device. Don't throw it, so I just put it here. I have to put the devices back. Yes. I put in the bag, in the box. Okay, no problem. Okay, everyone read the tokens? Okay. Okay. While you read the token, I go on with the data. Okay, since this is a MyFair ultralight ticket, we have initially we have the ID of the ticket, which is the same as you can see here. This is the UID of the ticket till here, and then we have some data I won't talk about because we are very late. But what we are interested now is okay. Okay, is this page here? Each page in MyFair Ultralight are made by four bytes. So this till here is a page from AE to 87. Everyone has the ticket? Not yet. Okay, wait a minute. Yes. Okay, this first page from 1F to FD is the OTP sector I talk about. Is the sector in which you can turn the 0 to 1, but you can turn the 1 to 0. And this is used in this case for storing the writes you have left. If you see the last 2 bytes, FF, FD, FD, if you transform it to binary, it's something like 1, 1, 1, 1, 1, 1, and at the end, 2 zeros, right? So in this case, we have still 2 writes left. When we stamp the ticket, one of those zeros is turned to 1, so 1 writes left, and we can turn this 1 to 0, so we can add new writes. So when we finish the ticket, we just throw it away. Then the other interesting things in this ticket is the timestamp of the data, which as soon as everyone has the ticket, I show you. Sorry?
Can the program copy the card?
Yes, depends. What card?
It's the red metro one. It actually shows the data.
It is an ultralight card, the red one. I don't know.
It's called Единый.
I have no idea. I don't know what the card is. So,
But it shows the data when you...
so it's probably a MyFair ultralight.
Yes, in the subway, the ticket type, call it Единый, it's MyFair Ultralight.
Okay, so you can clone it, but it doesn't mean you can have free rides. It just means you can create a copy of the ticket, except the UID, which is not writable in the normal tickets, in normal MyFair ultralight tickets. Can I have the cards back if everyone read them? Who has the cards? Ah, they can read it? They can? Okay. AE to 87 was the timestamp of the ticket, and it was stored like the minutes from a zero time, which was the 1st January 2005, and then they start counting the minutes, and they write this number in hexadecimal in the ticket. So you can modify this time, you can stamp the ticket by yourself at the actual minute, without touching the OTP sector, so without removing writes. And doing that, you can have also, you have a ticket which is stamped in the moment, and is valid for a fixed amount of minutes, like 90 minutes or 100 minutes, depending on the implementation. This was the first problem. So when we do that, they said, okay, and they started to make an encryption of the data. Doing the encryption, we bypass the encryption using Chinese clone ticket, which are writable in every page, UID, and the OTP sector is not locked as before, so we can turn the 1 to 0. So we create exact copies of the ticket and just modify the OTP sector to have infinite writes. This was possible because there were not an online check, a database with the UID of the tickets. So they cannot they cannot check if the ticket has the rights. They have to trust the data on the ticket. Okay, I'm sorry the hands-on part is a little bit late. I have to go on. Sorry. Okay, I need to jump this. Case studies was something like I showed before. You have the UID, the OTP sector, and these are the timestamp for another implementation. We could modify the timestamp and get free writes. This was my first classic, which was used to open the door of an hotel in Italy. And as you can see, there was the UID, which this was maybe a 7-byte UID. I didn't clone it, I didn't emulate it, just broke the encryption, and then one of the pages shows the room number. So we can modify the room number and enter in another room. There was, again, here, there was no control on the backend system. As you can see, the schema was just this part here, which is colored. There were no controller, there were no backend system. All the checks were made offline by the readers. Okay, module 3, attacking radio frequency communication. When you finish with playing with the Hydra bus, please give me back so I can give you the other hardware. And I go very quickly, sorry. But we have like 20 minutes or something like that. Okay, radio frequency is used to automatic identification as a high reliability, so we can have also a safer distance for reading the tags or reading the token, and can work in low frequency, high frequency, and ultralight frequency. Usually when we speak about radio frequency communication, we have ultralight frequency, so 433 megahertz, 860 megahertz, or 2.4 gigahertz, like Bluetooth, Wi-Fi, whatever. Low frequency are usually used for tags or very old access control systems. High frequency is used for locks, for ticketing, and for more modern access control system, as we see before. Then we have ultra high frequency, which is used for gates, keyless entry system for the car, if you don't have to pull out the car from the key of your car from the from the pocket, whatever. Smart alarms, smart locks, they often use like Bluetooth low energy, stuff like that. So we have fixed code, rolling code, NFC, Bluetooth, Zigbee, Z-Wave. The last two are very common in IoT ecosystems. So it's very interesting to look on those protocols. Okay, how can we explore wireless communication? We can use a software-defined radio, which is a device which can allow us to move in the frequencies domain and see the actual signals which are present at the time. It's a cheap hardware and very flexible because we have a very wide range of frequencies. These are maybe the most famous devices. We also have the AirSpy, which I forgot to put, but we have the RTL SDR dongle, which is the cheapest one, about 20 euros, and you can go from 24 megahertz to 100.5 gigahertz, 100.7 gigahertz, more or less. It has not a narrow bandwidth, 2.4 megahertz. Then we have the HRF, which probably all of you have heard about, which has a very wide range, but the bandwidth is not so big. Instead, the USRP, which is the most expensive one, has a very wide range and a quite wide bandwidth. The bandwidth is the amount of signal you can see in each moment. So if we put our center at 100 megahertz, with the USRP, we can see 28 megahertz behind the zero and 28 megahertz up front the zero. Then we have a software, of course, to communicate with these devices, which is GNU Radio. GNU Radio is very interesting because it's easy to use, not so easy to understand, but very modular. We can create our own blocks. We can perform signal processing in a very advanced way, and everything is in a very simple graphical experience, which is this one. As you can see, GNU Radio Companion is this software. We have blocks. Each blocks perform an operation. Like, for example, this is the most easy program you can do with GNU Radio. We just have a source which tells the program where to get the data, from. In this case, we have the RTL SDR device, which is this one, for example. There are many versions you can find online. In which, in this block, we can set a series of parameters, like the frequency we are looking for, the sample rate we want to use, and a series of gain for getting a better result, have a better view of the signal. This is like a plot of the frequency domain, in which we can see the frequency, the power of the signal. And we can spot, in this way, we can easily spot a signal, where is a signal, and intercept that data specifically, with avoiding some noises, whatever. We can use filters if we know exactly where the data is. Okay, this is the characteristics I told you before. We have the frequency. In this case, we are working with the 434 megahertz. We have the sample rate we are using, which is stored in a variable called sample rate, which is this one. In this way, if we modify this variable, every other blocks which are using this variable will edit the value as well. And then we have the gain. The gain with the RTL SDR dongle can also be set in automatic mode, which is very convenient. And it automatically adjusts the gain with the signal is getting from the air. And this is just a plot, just show you visually the signal, the frequency domain, sorry. Again, we are using the same variable here for the sample rate. We are using FFT size, is the amount of data is converting, is using for the fast frequency transformation to show you visually the data, the frequency, and then we can set the frequency, refresh rate, so how many FPS you are seeing on the screen. And the result is what we saw before, which is this. If you have something which is not clear, please ask me later, because I really have to go very quickly because it's very, very late. I'm sorry. Okay, now we should receive our first transmission. Again, we will use the tools in the virtual machine, and I will give you a dongle. If you want the dongle, please bring back the Hydra. And with the dongle, we can receive the first transmission, and then, using the same dongle, you will also be able to do the challenge and maybe get one dongle for free at the end. So please, bring back the Hydra, and I give you the dongle.
Here you go. Should I disassemble?
I will do it. Okay. Everyone, you can use also the smaller antenna. I know it's fun, but okay, whatever. Okay, if everyone connect the dongle to the computer and open the VM. Yes. Yes. Okay, and now in the virtual machine, you will see this program here, which is called GQRX, which is a graphical interface for analyzing the signals and is based on GNU Radio. So if you open it, okay, this is the interface you should see. In the upper part, we have the frequency we want to connect, and here we have the plot, which at the moment we don't have because we didn't start the program yet. And on the right side, we have some features we can set. So let's try to start it with the button here, and you will see some signals here. Now, if you recognize the frequency, this is the frequency for FM radio. So if we move if we tune our dongle to one of those signals on the pike of the signals, and we go to the receiver options, we have some decode mode, the modulation mode, sorry. If we select an narrow FM, we should be able to see, okay, my virtual machine just crashed. But you will be able to hear the radio station. Oh, fuck. Does it work for you? Can you tune you see the plot at least? Okay, can you tune to one of the pikes and select narrow FM as the modulator, which means it is taking the signal and demodulate it with the frequency modulation and try to to give you back an audio signal. Fuck. Okay, I'll try to restart my virtual machine.
How can we connect the dongle to the radio software?
What do you mean? The software recognizes the dongle. Should recognize the dongle. I arrive.
Devices were connected and we have
Sorry? Okay, you can see there are several pipes here. Each one is a different radio station. So if we tune our dongle to one of those and we set as demodulation narrow FM, and you raise your volume, you should be able to hear the radio. Does it work? You can also, on this side, raise or lower the volume. Of course, with the virtual machine, some of the computation are not made very well, so you may hear some like it's trying to keep up to the frequency, but it doesn't work very well. If you do this in your main machine, you will be able to get better results. So, anyone has some problems, something? Which, yes?
I see devices, but we can open the computers. So this one? Yes. Okay.
very quick overview of the software, so you can use it later for solve the challenge. So as you see, here we have the modulation we are using, and we also have row and amplitude modulations. If we set row, means we don't know the modulation used to transmit the signal. We just save all the data and try to demodulate it later. With the AM is the classical amplitude modulation, and then we have a series of other modulation used, for example, to get the data from satellites or whatever. From here, we have also a rec option, which records the data and save it to a WAV file, which can then use later with the software like Baudline or Audacity to see. We can zoom the signal, we can see it not from a frequency domain point of view, but from a time domain point of view. You all know the difference between time and frequency domains, right? Okay, no problem. It's not a physical lesson. So, going back to the presentation. Okay, very quickly, signal intelligence, what does it mean? It means trying to understand an unknown signal and trying to decode it and get the data which the signal is transmitting. We have 3 steps. We have to intercept and record the signal. We have to study its own characteristics and reverse the transmitted data. Starting from the first step, we can use GQRX, which is a SDR receiver and a spectrum analyzer. It's user-friendly. It supports several SDR, the dongle, the AKRF, USRP, and other, and can record easily the signal to a WAV file. This is the interface you saw before. In this case, we have no signal here. You can also work with the gain to get better results. In this case, we are getting a signal. You can see quite easily the burst of the signals from a car key. If you save this signal to a file and then start studying the characteristics of the signal, you can actually see the 1 and the 0s sent by your car key to the car to open the door, to close the doors. Okay, this is just a very theoretical part, which I will skip it. If you are interested, just open your Physics 1 books and you find it. It's very easy. Just show you how a signal is modulated. We have a carrier wave, and we have a signal. We put them together in different ways, and we finally have the final signal, which is, for example, in this case, amplitude modulation. As you see, the amplitude of the signals varies. In this case, we have frequency modulation. The frequency of the signals is what varies here. Then we have phase modulation and more complex ones. One interesting site for identification of signals is this one, cgidwiki.com, in which are present a series of already known signals and modulations. So you can compare your signal to those ones and try to understand what modulation is used. If you remember the slide before, this one, in which we are getting this signal as this behavior, and we confront it with the site, we see that it's very similar to this one. So we can suppose it's an amplitude modulation. And now we can use software like Audacity to study the signal in a very interesting way, because we can open it from the time domain and analyze the bit of the signal. I show you with a case study, and then we go with the challenge. So we recorded the signal using GQRX and the record features, and we open it with the Audacity, and we have something like this. If we start zooming in, we can see that each of these lines are in fact something more complex, something like that. And it's from just viewing these graphs, we can easily spot this is probably an amplitude modulation, because as you can see, there is just amplitude levels that changes, and since there are only two levels, it's probably a OOK modulation, which is on-off keying modulation, which means the signal can only have two values, 0 or 1. And so the other difference is the length of the signal. So we can decode it in this way. We take this first signal and say this is the start of our communication, and from that point on, all the other signals are actually bit of the data. And so we can find something like this. As you can see, the first one is the starter of our signal, and then we can say, okay, this one is a 0, this one is another 0 because it's similar, and then we have 1, 0, 1, etc. So at the end, we get the final message, which is this one. This was from a door, from a gate, and was using a fixed code. So if you know this signal and you can retransmit it, you will open the door, because there is no change of the codes during the time. So since this is a problem, they start doing rolling code, which based on the time and on the token, they change the codes dynamically. So the rolling code, the remote send always different codes, and they are synchronized so that they both know if the code is correct or not. And only if the code is correct, they open the gate. And even if you intercept the code and reply it to the gate, it won't open, because of course the code is not valid anymore. It's already been used. But it's not unbreakable. There is several research on a very famous algorithm called keylock, which was used and is still used for opening cars, for example. And they broke several mechanisms, several security mechanisms of the keylock. Okay, we have 5 minutes. I don't know. Let's try with the challenge. Okay, this is the challenge. The name, I'm Italian, the name is totally random. The name of the organization. It's not made from hacking team. It's hackers team. It's a completely different organization. So you have to intercept a code I will transmit and try to decode it. And then bring me the result, the bit as we see before. I want this result. You can use jQueryx, you can use Audacity to open the file you saved and start zooming and check the codes. The interesting thing here is that you have to find the frequency first, the frequency of the code.
Code transmitted now.
No, not yet. I will transmit it now. Just need to take the hardware to transmit the code. That your dongle cannot transmit data, can only receive data. This SODR can also transmit data. And there's a wider range of frequencies. So it also costs like 10 times your dongle. Okay, now the signal is being transmitted. You should find the frequency first. Using GQRX, you can move along the frequency domain, try to find it. Sorry? Yes, it continuously transmit the same code. Okay, you may find a remote controller from one of the employees of the evil company, but you can use to open the gate. You decide to open it and see what's made inside, and the controller is this one. It may give you some hint on what is the frequency you need to look for.
How long is it gap between the transmission? Time of transmission.
Oh, it's continuously. Yeah. No. It's if you don't see anything but you think you are on the right frequency, try to work with the gain, try to increase the gain of the receiver. At the moment, I think the gain is set automatically, so you should be able to see the signal.
How would it look like, the signal?
Sorry?
No, never mind.
Can you please stop for a moment?
To transmit the signal.
One moment.
Okay?
Let's stop.
Yeah, it stopped.
Now stop.
Now it started.
Can you stop once more?
Yes? Stopped. Thank you.
Okay, can you start?
Sorry. Okay, it started back. Did you find it? Okay. This image show that the remote you found has an oscillator which is oscillating at a certain frequency, which is written on the oscillator itself. Do you see the number on the oscillator? 13.9? This is the frequency at which the oscillator oscillates. So if you try to look at the... Okay, thank you. If you try to look at that frequency, 30.9 megahertz, you will see the signals here. And here. Do you see the signals at that frequency? So anyone saw the signal at the frequency and save it to the with the recording features and try to open it with Audacity, or you don't see anything? I have to give away some of the dongles, so someone wins, please. Control if you have this checkbox checked, because it automatically adjusts the gain based on the signal on that frequency frame. I think we're out of time. We have still some.
1 hour.
What? 2 hours. I had 2 hours. I thought 2 hours. I thought 2. Okay, no problem. Okay, I keep going. Okay. Okay, no, I was completely wrong. We still have 1 hour. So, how many of you saw the signal here? Okay, one over there. So the signal arrived at least over there. You saw the signal? Perfect. Anyone else?
How can we scale the image?
What do you mean? Zoom, like zoom in? Okay. Why you want to zoom in?
Just to decode it.
Okay, before decoding, it's better to transform it in time domain, so you can actually see at the time the transmission. To do that, you can save it with the record feature, and then open it on Audacity.
But how do you save it as a recording feature?
Sorry?
How do you save it? Because
It's here. Wait. On receiver option, you have, wait. This is the IQ recorder, or you can use the recorder feature, which should be, see here, on that. Oh, come on. Okay, here, you see? There is the rec button. It records the signal. Real world scenarios, the transmitter is tuned to the exact frequency it's transmitting, of course. So actually the code you are reading or you are trying to read is created from this device. So this is a real code. And I show you now how from in the real world the code will be represented. So this is the file I'm transmitting. If I open it with Audacity, the real code I recorded before the challenge was something like this. As you can see, it's very, very clear. And I think it's a problem of the HackerF. Don't know why. In my hotel room, it worked flawless. And zooming in, okay, you have the starting frame of the transmission, and then you have a series of bursts of the signals, which are similar. There are two different kinds of bursts. This one, which is a little bit longer, you start from here and arrive till here. Then we have another one, exactly the same one. It doesn't matter if a 1 or 0. You don't care actually. You just care that is the same code. At the end, if you reply this code, the gates will open. And if you try to decode, decoding the code is very interesting in some cases, because what we found from our experience is that maybe a building has more than one gate, and they use a similar remote controller for all the gates, maybe with different buttons. So what does it mean? It means that the code for all the gates are almost identical. Maybe they just change the last 2 or 3 bits of the code. So if you can decode the signal, you can modify it to try all the possibilities, try to brute force the signals, and even if you have a signal from one gate, you can guess the signals used to open all the other gates of the same building. And that happened once. We were able to record a signal from a perimeter gate, but then once we were inside, there was another gate for the management parking, and we wanted to get there because there was no security control. So we didn't have the signal for the internal parking, for the management parking, and decoding the signal and brute force the last 3 bits of the signal, we were able to recover the correct code for the internal parking. So that's why we are not just replying the code, but we are trying to see how to decode it. From another point of view, for example, if you do research on custom radio frequency communication, you may happen to see some IoT devices which are implementing some custom radio frequency communication, or some alarm system which has its own radio frequency communication. So it's important to be able to decode it, because maybe the same code with just a little part of differences is used for starting the alarm or stopping the alarm. So maybe you are able to record the signal for starting the alarm and decoding, and try to understand the data. You can also forge a valid signal to stop the alarm or stuff like that. So I'm sorry that the HackerF doesn't transmit enough well to you to be able to see it. So instead of giving away the dongle to the first 3 to decode the signal, I will give away the dongles to the people with the most interesting question. Do you like the idea? Do you have any questions?
We have 14 beat signal right now.
So, what?
In this particular
Yes.
call, we have a 14 beats, am I right?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes. And then, as you can see, this is the first burst is used for the gates to say, okay, is coming as a valid signal, is coming a signal. I have to read to understand it and try to decode it to see if they're the correct one and open the gate. Otherwise, there may be noises which act like a signal, and the gates maybe is not able to make a difference between the noise and the correct signal. With a starting sequence, we can say, okay, now there is a real signal. It's not just some noise.
And which bits in this particular example should be changed?
Usually, in this particular example, I don't know, but in another real-world example, the last 3. Some old controller, if you open it, like, okay, you can, no, okay, it was in this part. There are some pins, the plastic pins, you can change, and if the pin is set to 1, the transmitter is sending 1. If it's set to 0, it's sending 0. In this way, change the pin, you change also the code. And if you have some old remote controller, you can see that often for different gates of the same building, of the same organization, the last 3 bits, last 3 switch are just changed.
And how did you reverse engineer this particular case to, and you understood that you should change it to those 3 bits?
Oh, we brute force it.
You just
Yeah, we started from the last one, then the second one, then the third one, and then the gates opened. So we say, okay.
you didn't know the manufacturer of this controller?
Yeah, it's written here. It's an Italian gate manufacturer. I don't know if there is also in.
Black box testing?
Yes, yeah, black box. We didn't know anything. We didn't have even the controller. They gave the controller after the test. Yes, we just waited in the car for someone getting inside, record the signal, and then brute force it to open the other gates.
But now, when you say brute force, the way you showed to us, right? So there is a Audacity wave.
Yes, you.
So I guess the brute force you do, you have to generate.
That's
the
true.
last 3 bits in the same.
Correct.
How you do it?
We do for generating the signals. We create our blocks in GNU Radio Companion, and in GNU Radio Companion you already have a lot of blocks already made by some other users, which are very useful for the modulation and modulation. So it's not so hard to create a sort of brute forcer once you understood how the signal is composed.
So basically, you try to repeat the same form, right?
Yes, exactly.
Using the GNU radio, and then you submit, instead of the waveform, you submit there basically 0, 1.
Exactly. We know what the 0 and the 1s of the signal, so we can use that. We know how a 1 is formed and how a 0 is formed in the signal, so we can generate these signals, put it all together, and try to brute force from the last one. From
In your particular example, so
Yes.
the longer was the 0?
Oh, it doesn't matter.
It doesn't matter.
Yeah, we just say, okay, the longer is the 0, the short is the 1. The important thing is that we know the characteristics of that signal.
So that your modulation produces what you expect.
Exactly. We just need to know how long is this burst and how long is the long burst. Just the time frame in which we have to put the signal to the high level, and the time we have to put it on the low level for the 0 and for the 1. And then we can generate how much 0 and how much 1s we want. In a real world scenario, usually you have to transmit it like 10 times each code, because the gates are not so clever, so they may miss some bits, or they may miss some parts, or maybe the transmitting device you are using is not good enough, like the ACRF, and so you can transmit it multiple times. Usually it's better. It slows down a little bit the brute force operation, but with codes that small, like 14 bits, it's not that hard.
And how do you reverse engineer the cards? So you just
Sorry?
How do you do it with the cards? So you just want the changes in the data, after trying and using the card, right? Because you figure out that, I don't know, a particular point of the MyFair card was...
We are talking about the NFC part. Okay, what we did, the cards I gave you had 2 different, is the same card with 2 different timestamp. So we stamped that card twice in the day, and we compare the data, and we see there is some pages which are different. One of them was the timestamp, of course, and the others was like the location where we stamped the ticket, like if we stamp it in the metro station or in the bus station or whatever. And another sector which changed was like the precise bus we were taking. So they can use this data also for statistics. And any other questions?
While it's presenting the signal, how do you determine which one the modulation to use, depending from the frequency and the spatial modulation? How do you...
Okay. Wait. If you see this, I showed before.
I mean, it's clear with amplitude and phasal modulation and frequency modulation, but what do you do when you're encountering phasal modulation?
In phase modulation, you just have to. Okay, we have two possibilities. One is to try to figure out using sigidwiki.com, which has a series of already known modulations. And you can try to spot if something is similar and try and error then.
So basically trying to visualize and analyze.
Yes, and after sometimes you see a signal, you you already understand what modulation is using.
So this is just a manual work, yeah?
You can't automate that.
You can't automate that, yeah?
Yeah, if you are good enough to create a tool that automates the non-modulation, well, send it to me because I will definitely use it. At the moment, I do it manually, yes.
So we got here that the quality of the transmitting signal is depends on the length of antenna.
Yes, that's true.
So if we are changing the length, we can get
Slightly better, yeah.
quality and maybe better and maybe close to
Yes, this,
the 1/4 of the wavelength, maybe.
yeah.
And
You should, to calculate the length of the antenna, you just take the speed of light, divide by the frequency you're using, and then divide by 4. So you have 1/4 of the frequency of the wavelength, and then you should try to use an approximation of that length or multiples or dividers of that length.
it works really
It works better.
Yes, we can get something similar. So here,
Okay.
here is maybe not so.
Yes, it's at least you have signals and not just noises.
No, not just noise.
Yeah, sure.
And percentage of the noise is less,
Of course. Okay.
and this is.
Yeah, that's
random.
it's just pure noise.
Yes.
And you've mentioned about vulnerabilities in the rolled key mechanism. Is it
In the key lock, yes.
is it solved out the productivity of key generation?
I think was something about that, like they were able to, in some way, I don't remember exactly, able to extract some secrets from the key lock chip. And since the key lock used also some secrets to encrypt the code and modify it.
To have a hardware chip to analyze it
Yes,
before the crash.
yes.
No possibility to crack it in line, just.
There is some vulnerability. I don't know if you last year at Black Hat there was a guy which did some amazing works also in his website. I don't remember the name, but he showed a vulnerability of rolling code. And what he did is we did the same as our own company. But what he did and present at Black Hat was to intercept a signal and jam it, then intercept the signal next to it, and then he reply the first signal to the gates so that the gates open. But he have a signal after that which is still valid. And then when he need to enter, he just reply the second signals and open and enter in the gate again. It's sorry?
It's not expired in time.
Sometimes yes, it depends on the implementation and depends on how long you need the signal to be valid. I mean, if you just need to wait the other guys get inside and then you can enter, you can just use it. The problem was that it's not very easy to do in real life because there is a lot of noise. You have to jam it at the perfect time. He tried to create a proof of concept version, like a little board with Arduino and some transmitter, but in real life it doesn't work every time. And that was one of the attacks on rolling code signals. I try to remember the name of the guy. It's quite famous, I mean. Any other questions? We also have some T-shirts to give away, right? Two T-shirts. Sorry? For the two best questions, I don't know. This guy made a lot of questions, so you won a T-shirt, white and black. White. And the guy over there, you won another T-shirt. Black or black? Good choice. You're welcome. Thank you. And then I will give away 4 dongles. So, come on, bring the dongles back, and I give one to the guy who spoke about the wavelength. Yes, you can keep your dongles. You want the dongle.
Yes, thank you.
One to to this guy who brought some hardware and show you, you want another dongle. And I don't know, who want to do some research in that field and wants a dongle? Okay, he was the fastest, but you want the t-shirt already.
Yeah. Can I have both?
No, no.
Oh, I'll give it to you because $20.
You want that and not the t-shirt.
I want both. But if you don't give me, I'll give it to you.
Okay, okay, perfect. Let's give it to someone else. You already have the dongle. There was a girl, since we have just 2 girls, I will give 2 dongles to the girls because we have very few hackers girls. So come here and take your dongle, or keep the dongle if you already have one. And last dongle to, I don't know, the first one who came here at the table.
Me.
He won. You're welcome.
Thank you.
You're welcome. Okay, if you don't have any other questions, I show you just the last slides. Yeah, that was what's supposed to happen, but it didn't work quite well. If you are interested in this kind of work, we are trying to sell some Hydra bus, Hydra NFC, some mini USB cable, a dongle, everything for 150 euros, which is the price of Hydra NFC plus the Hydra bus. So you can get for free like some cables, the dongle, some breadboard, and a MyFair ultralight card. If you are interested, just tell me. I'll give you everything. You are interested?
I just got one question about the hidden bus. Does it allow
Yes.
to write values to the cards, or it's read-only?
At the moment, it's read-only, but you will be able to emulate and write. The interesting tools here is also the Hydra bus, which can be used to. I don't know how many of you know the Pirate bus Pirate. Sorry. It can be used to connect and communicate with.
Very, very difficult to use. Row, pin-outs.
You mean the Hydra bus or the bus Pirate?
I mean the Hydra bus shield and the bus pirate communicate.
Oh no, I mean the bus Pirate and the Hydra bus can do the same jobs. The Hydra bus can communicate with a lot of different hardware interfaces, like I2C, like CAN bus even. So if you want a very small board with a lot of capabilities, the Hydra bus is very useful. Also, if you have some like hardware boards and you want to connect to the EEPROM memory or to the chipset, you also have JTAG capabilities. That for a device with this low price is very awesome because it can also help you to identify the JTAG pins, brute force it, a lot of interesting stuff. And the Hydra bus and the Hydra NFC, of course, is open source, so you can both download the firmware or contribute to it. At the moment, there is just one poor guy who has developed the firmware, so you can, if you have the experience to help him, that will be great. Well, that's it. Thank you. Thank you very much. If you have feedback for the presentation, this is the first time I gave the presentation, and as you can see, there was some errors during first the virtual machine, then the transmitting power was not enough. So any feedback is appreciated for the future. So thank you.